Hey there, it's Michael Cantor, president of Hashgraph Online. And today I'm going to teach you about three new standards that we're working on at Hashgraph Online: Petals, Floras, and state hashes. And these are all new coordination standards or specifications for managing accounts and creating appnets. So let's jump right in. One of the cool things about Hedera that most people don't know is that you can have many accounts that use the same private key. In fact, you can have many different entities that use the same private key. You can reuse private keys all throughout the Hedera ecosystem. So that brought us to an innovation we thought about called petal counts. The idea behind a petal count is suggested, but you don't have to do it this way, is that you have a single ECDSA key, and then you can reuse that ECDSA key to create multiple petal accounts. So each of these petal accounts will now be able to sign transactions, transfer assets, and so forth. But they're all unique account IDs. And that's really great because what you can do with these is you can pair them with our other specifications like HCS11 for profiles. And then you can generate unique profiles to do certain things, like maybe managing your DeFi portfolio or logging into a social media app. Each of these accounts can now be broken up by their identity, their holdings, and assets that you're managing. Puddle counts are also really important as they dive into the new coordination layer that we're working on called Floras, or in other words, appnets. Appnets is a word that you might have heard about before. A Flora is just an account with customized rules on its consensus. So, for example, a Flora can define two of three consensus. And essentially, that means that the Flora's public key is actually a threshold of these rules that you put. So the threshold might be that two of three consensus, meaning that you need at least two out of three accounts, if you've got three accounts in this threshold, to agree and sign the transactions. And you might have heard other words described this before in the past, like multi-sig, right? But the difference between a Flora and a typical multi-sig is that we're actually using HCS to manage all of the actions, record the state, and so forth behind this appnet. So it's a more advanced use of a multi-sig account in this way. So each petal in the Flora would have ideally its own private key, and it would run the same software, but in geographically independent locations to avoid collusion. So, in a more practical example of this, isn't exactly clear to you. Essentially, you would have this Flora account. Flora account can't do anything unless all of the petals associated with the Flora account agree on the thing. So each petal might be running a piece of software, and that piece of software comes to an agreement on something. Maybe it's the price of an asset. We send over that price, and then each petal sends it to the next petal, and so forth. And then they sign a transaction agreeing, yes, this is the price that we were talking about. So the Flora, there are three topics that they coordinate on for their appnet. There is a C topic, which is for the communication, and that's it can use HCS10 for this, for example. So this is where all the members of the Flora can chat to each other, propose governance votes, and negotiate off-chain data. It can be human readable, or it could be managed by agents through a large language model of some sort. You can kind of think of it as the communication vertical for all the petals. Again, remember, these petals should all be geographically independent from each other, running ideally in different data centers or bare metal servers, or maybe even different accounts or computers. Then you have a T topic. The T topic is the transaction topic. This is where the petal accounts can all coordinate on transactions that need to be signed. So in a practical example, a petal says, okay, we need to send 10 bar to some account. It creates a scheduled transaction, and it puts it in the transaction topic ID. Now, the other two petals in the floor, they scan for this incoming transaction, they agree, and they sign it. Or one of them might decide, no, I don't think that's a good idea, and the transaction never happens. Lastly, there is the S topic. The S topic is a state topic. It is a cryptographic proof that shows the current state of the floor. So if your appnet is coming to consensus on something, let's say it's the price of an asset at a certain period in time, all of the petals will come together. They should generate the same state hash, and that state hash will now go into state hash topic, and that is a proof showing the current state of the AppNet. The state topic is a SHA-284 state proof of the current state, and it proves that consensus inside the Flora. So, for example, you could use the state topic for things like asset prices, database entries, or an index of all the items in the registry. We've actually built a more practical version, as I kept mentioning price over and over again, because we have this open sourced in GitHub. It is a floor price oracle, and there are three adapters in this oracle. So they go and they pull down the price in Binance, CoinGecko, and the Hedera exchange rate API. And then they all agree on the current price and epoch. And once they all agree on that price, it goes in a state proof. And then you can hit an API that's powered by these three Petal accounts, which has the current price. So I encourage everyone to go check on our GitHub under the Price Oracle repository and take this one for a spin. Thanks, everyone.